back to Springton Math Day. Today we're going to be exploring the content review or the chapter review for all the things we've learned in this chapter. Let's get started. Okay, the first topic we talked about, guys, was integers with exponents. So let's review some of the rules we discussed that have to do with integers and exponents. The first one was product of powers property. Basically, what we're doing is we're going to keep the base and add our exponents, okay? So the example we have here today is 5 raised to the second power times 5 raised to the third power. We add those two exponents together. So the exponent of 2 plus 3 is going to give me a final exponent of 5. So the final answer in this particular equation is 5 raised to the fifth power. Okay, power of a power property. Okay, so in the word format, this means to find the power of a power, we're going to multiply our exponents. Now we just added them. In this case, we're going to multiply them, so pay attention to the difference. Now we have 5 raised to the second power inside the set of parentheses. And the entire equation is being, or expression is being raised to that third power. So we have to multiply 2 times 3, and we get 6. We keep the base of 5, so our final answer is 5 raised to the sixth power. So when you see an exponent being multiplied by something on the inside that already has an exponent, we're going to go ahead and multiply the powers together. The last rule we discussed was the power of a product property. Basically, we have to remember what the distributive property is so we can distribute the exponent on the outside of the parentheses to all the items that are on the inside. In this case, we have 5 times 2 on the inside of my parentheses, okay, and the being raised to the fifth power on the outside. So we're going to distribute that power 5 to everything on the inside. So I get 5 raised to the fifth power times 2 raised to the fifth power. You can see clearly that the exponent of 5 is now being attached to both the 5 and the 2 as their bases. Okay, next topic we're going to review today, powers of 10. It can be written as an exponent form where the base is 10 and the exponent is n, which in this number of times 10 is multiplied by itself. Basically what this looks like is 10 raised to the nth power. And the n is a number that can be anything from 1 to 1,000,000. So here's some examples of powers of numbers of 10. 10 raised to the first is really like 10 times 1, which is 10. 10 raised to the second power is 10 times 2, or excuse me, 10 times 10, which is equal to 100. Now what I just said was a mistake that many people make all the time. I'm glad I caught that. And we have 10 raised to the third power, which is 10 times 10 times 10. 10 times 10 is 100, and 100 times 10 leaves us with a final answer of 1,000. So some things to remember. When you have a positive power of 10, we're going to move the decimal place to the right. In our example here, we have 4.567 times 1,000. Now I can also have written this as 4.567 times 10 to the third power. Those 3 zeros, or that third power, tells me to move that decimal 3 different spaces. So we get a final answer of 4,567. When you have a negative decimal or a negative power of 10, we move the decimal to the left. So 6.7 times 10 raised to the negative 1, we're just going to go ahead and move that decimal place one spot to the left. Because that's the negative exponent tells me to move to the left because that's where on a number line, the negative numbers are on the left side of the 0. So we get 0.67 as our final answer. Okay, topic 3 discussed in this chapter, scientific notation. As a general definition, we can say that a number is expressed in scientific notation when it is in the form of n times 10 to the nth power. Now the first part, the big N, it has to be a number between 1 and 10. And that n also has to be a regular integer. Okay? So the example here at the bottom is 2.8 million, which can be compacted in scientific notation format to the short expression of 2.8 times 10 to the sixth. Positive powers. A power that tells you how many decimal places to move. The positive means we're going to go ahead and move that to the right. So 2.08 times 10 to the fourth power. My exponent is positive, so we need to move it to the right 4 different spaces. So go ahead and move that decimal 4 spots. Did you get 20,800? If you did, great job. Again, that positive number exponent tells you to move to the right side. Negative powers, as you could probably guess, tell us to move to the left. Okay? So 2.08 times 10 to the negative 2. The negative 2 exponent says I need to move 2 spaces, and the negative part means I need to move to the left-hand side. So I get 0.0 0.208. You can see clearly the decimal place moved 2 spots to the left, and we came up with an extra small number. Okay, topic 4, scientific notation and measurement. Scientific notation is frequently used in mathematics and science. It is a way of representing very small numbers and very large numbers without having to write all those extra zeros on the end. So here, let's look at some of those examples. The first one we have here is a very large number. In this case, 595 million. Okay, so we're going to go ahead and shrink that number down in a compact form, just like we talked about for scientific notation. We have 5.95 times 10 to the 8th power. Okay, I moved my decimal place 8 times, so that's where I got that exponent of 8. And you can see here at the bottom, I have a very, very tiny number that falls between 0 and 1. In fact, you would need a microscope to see how small this is. Your regular human eye would not be able to see it. And that comes out to 1.7 times 10 to the negative 11th power. So just a quick review of that again. Notice that the first number is very large and has a positive power for exponent. And the second number is very small and has a negative power of 10. Last topic we discussed in this chapter, scientific notation and the operations that go with it. So the key to evaluating expressions with scientific notation is to group the powers of 10 together and deal with the other items on their own. So let's look at an example. 3.2 times 10 to the 6th power times 8.7 times 10 to the 11th power. So we need to separate those items. In one set of parentheses, I now have 3.2 times 8.7. In my other set of parentheses, I have 10 raised to the 6th power times 10 to the 11th power. We've separated them. Now we need to deal with them individually. So 3.2 times 8.7 gives us an answer of 27.84. Now I also added my exponents in my previous page, and I got 10 raised to the 17th power. However, we're not quite done yet. You can notice here that 27.84 does not fall between 1 and 10. And we need to figure out how to make that number fall between 1 and 10 so we can say that we have an expression that's listed in scientific notation format. So we need to move that decimal place 1 spot to the left. Let's go ahead and do that. I now have 2.784 instead of 27.84 times 10 raised to the 1st times 10 raised to the 17th. Now we know from previous chapter that we need to add those two exponents together. Our bases are the same, so we add our exponents. And we get a final answer of 27.84 times 10 to the 18th. That's it for your content review, guys. I'll catch you in the next chapter. Good luck.